all the participants to kindly mute your microphones during the presentation, please, because towards the end of the program, you may unmute yourself and ask the questions, requesting everyone to kindly cooperate. Very good afternoon, fellow Foundrymen. It gives me immense pleasure in interacting with you all for the 20th technical webinar for the year 2022-23, conducted by the Institute of Indian Foundrymen Chennai chapter, online through Microsoft Teams. We are today having a talk on refractory materials and bricks. We all know how important refractories are in the productivity of a foundry, and effective utilization of the same will benefit the foundries in a big way. We are fortunate to have with us today Mr. Sanjib Kumar, a specialist who can give you solutions on today's topic. We are sure the webinar will be an excellent knowledge sharing session, and you will have many takeaways from the session. It is now my pleasure to introduce our speaker for the day. Mr. Sanjib Kuma Chakrabarti is a graduate, B mechanical graduate from Howrah, Calcutta University, and MTech Industrial Engineering and Operations Research graduate from IIT Kharagpur in the year 1975. He has a total work experience of 47 years in corporate sectors and teaching, and he has worked in Future Institute of Engineering Management in West Bengal as an assistant professor in the Mechanical Engineering Department from 2010 January till 2012 of July. Gargi Memorial Institute of Technology as an assistant professor, and then guest honorary at Ramakrishna Mission Tech School, Narendrapur, and visiting faculty in Indian Institute of Social Welfare, Business Management, and visiting faculty at Kalyani Government Engineering College. Industry experiences: he has worked in SAIL Bokaro plant, Dhanbad. He was a junior engineer from 1975 to 98. Sorry, 1975 to 1970. Industrial Engineering Department. Sigma Consultants Private Limited, Calcutta, management consultant from 78 to 80. Texmaco Calcutta as assistant manager, and a freelance consultant, industrial engineering and OR from 1985 to 2010. So he is also a chartered engineer and valuer approved by Honorable High Court. So it is indeed a pleasure to have a illustrious speaker in our midst. So Sanjib sir, the floor is yours. Dinesh, you may
have the screen, sir.
Good. It is my pleasure to welcome you all Foundrymen. And though I am a mechanical engineer, the subject topic I have selected in my the course of discussion is of immense importance in the foundry industry as well as the steel making and all metal industries. This refractory, as you know, always it is a very important ingredient of a foundry, though it is not directly used. It is an indirect used, and it's a we call the it is a supplementary use for the furnaces and furnaces lining and furnaces efficiency, energy efficient furnace. And today energy is so costly. And not only that, the refractory also if the misuse of refractory or the non-utilization of refractory, or it is a abnormal behavior of refractory, they cause a downtime. So you lose the productivity. Since I spent a lot of time in the productivity in industries, including the heavy engineering and steel industries, I found it is an immense importance to look at the refractory aspect of it. Today I will give a glimpses of. I am neither a metallurgist nor a chemical engineer, but still with my years of experience, I find this is a very important topic to discuss with. And the next slide, please. Next slide. So first I say that what are the refractory, what it's used for. Refractory is a very hard material, and it is used as a liner for factory on the chemical vessels, chemical process factory on the furnaces, and it is very stable material and particularly heat resistant material. When there is a heating furnaces, there is a heating is there, then you cover up the heat, or you don't allow the heat to go away. So you don't waste the heat. So this way, it is a chemically a very stable compound, and It's a very mechanical, also hard, and it has a very peculiar property that it is a very non-reactant to anything, neither heat nor chemical activity, not chemical corrosion and erosion, all these things. So it is basically very material which having very property of very or resistant, heat resistant material and the chemically resistant material. And it has certain features. It is a low thermal conductivity, low electrical conductivity also. So mostly what are the materials are mostly the oxides, carbides, nitrides of silicon, aluminum, magnesium, calcium, boron, chromium, and zirconium. So these are the some of the very rare materials, and we are lucky that India has abundance of such materials in the earth crust. So we can extract it. These are the minerals. Basically, these are the raw materials are minerals, and we process it and use it. So the use of refractory, just we elaborate. It is a insulating heating system. It insulates the heating system so that the heat is contained in the process and best utilized. It is used in all metallurgical processes, furnaces, cleaning reactors, even in the petrochemical industry, in thermal industry, in your power sector also. It's a very wide applications of it, of different kinds of variety. And it is also refractory is something which is used or it is being as a support system to structure normally convey the heat from the process to the structures and other your environment. So it is called the insulating system. It is a kind of insulation to the other part of the structure. So furnace refractory prevent corrosion and erosion within the furnace. Even the inside the furnace, the cylindrical, say for blast furnace or any cupola, inside the furnace, the refractory is the layer which prevents corrosion and erosion of the furnace wall. And when the hot metal and slag are in contact with this. The characteristic, how is the characterized? The refractory materials are physically very stable, as I told you, and it is a high volume stability. Use of refractory, the insulating, other uses that heating elements. Refractory has the conducting refractory has other heating elements. The silicon carbide, tungsten, these are the heating elements in other chemical processes like hydrogen reformer, ammonia primary, secondary reformer, cracking furnaces, catalyst cracking system, utility boiler, like this. Ingredients for. So these are the pictorial representation of refractory. The gray is a grayish white color. Sometimes it's rough, sometimes it's finished, and is a clay block. Is a fire clay block. I've shown you in the picture. So shape and size of a brick. Shape and size of the brick is a different kind of. This is the formal shape, the standard shape, as per American Society of Material. Your ACE team. All the this is the size. We are the sizes. The straight refractory, arch refractory, in the arch, wedge, key. These are the standard shape. Some of the standard shapes are like this. These are being available, and these are these are the molded products. It is not cut. These are molded products, and since refractory is a ceramic material, so it's a powdery form. You have to make it by powder from different grinding. Different ingredients are being in the form of powders mixed and molded. The refractory materials, these are the features. The refractory materials are resistant to decomposition. It doesn't melt. Normally, it doesn't melt at low temperature. It doesn't soften the material. Material not getting softened by temperature, pressure, chemical attack. Refractory materials are polycrystalline. Basically, it's a polycrystalline, polyphase, inorganic, non-metallic, porous, heterogeneous materials. Very, very funny materials having low density or the low bulk density. Refractory materials also used for liners or melting and heating furnaces. As I already told you, reactors, incinerator. refractory materials are also used for the molds and crucible, mind that, or even glass and metal casting. We sometimes have the material, the refractive property has its conducting refractory. We call the conducting refractories. We use quite a mold, carbide, your silicon carbides, graphites, crucible, silicon carbide molds, heating elements like this. These are the different kinds of usage other than the lining material and the refractory use. It is also used as a mortar. It is also used as a mortar, like your construction work, be like the plaster. We have to do the plastering, and mortars used in joining two bricks. When we lay the bricks, it's used as a mortar, and that mortar is also a refractory material, ramming mass, etc. So, what are the constituents? The natural refractory materials is the silica. These are the natural refractory materials available in our earth's crust. You can get it in the earth crust by digging or a level of 5-6 meters or 10 meters. The silica, alumina, fire clay, dolomite, bauxite, chromite, magnesite, zircon. These are the all available, and India is quite rich in these materials. And we have refractory metals and alloys. So we have the refractory metals and alloys, as I told you, the molybdenum, niobium, tungsten, and tantalum. These are the metals will conduct heat. But its melting point, the refractory has the option of having very high heat resistance. These are material doesn't melt much. Their melting point is quite high. So that is why it is a refractory material, but it conducts heat. These are the heat conductive refractory, as I told you, silicon carbide and zircon carbide. And these are used quite heavily in high melting point situations. But only constraint is that you cannot do any oxygen. Any oxygen cannot be used. Any oxygen, allow the oxygen to pass in here. So high temperature refractory, binary, ternary refractory. This is a high temperature refractory. Binary compounds such as tungsten carbide, boron nitride, hafnium carbide, a binary compound having very high melting point, 3890 degrees centigrade. Ternary compounds such as tantalum hafnium carbides has one of the highest melting point as 4215 degrees centigrade. Mind that there are refractories that are many ways used in space shuttle, spacecraft, the launching pad, where we have very high heat generations are there. Deflectors in the launching pad where the gases and the things are coming out. These are the deflectors that are used. But now these are the real insulating refractory. The silica and aluminium, other side, the inner side is the direct contact with the hot metal. The other side of the vessel is the so classification of refractory. So refractories are classified on the basis of following: chemical composition, method of manufacture, based on fusion temperature, based on refractoriness, and based on thermal conductivity. These are always all the attributes for being a refractory material. And the classifications are as follows. First, we go to the chemical composition. So this I am showing a photograph of how the refractory is there. The right side is all the molten metal side. In between there's the shell, and other side is the insulation material. The right side refractory is direct in contact with the molten metal and the product of combustion. So these are the most severe conditions they are facing it. Inside the shell, or this is the half of the cell we are showing it in the sectional view, and the cell is in between, and this side, right side, is this one. Next cell. The refractory based on chemical composition, acid refractory. There are types of refractories: the acid refractory, basic refractory, and neutral refractory. The first is the acid refractory. Acid refractory composed of acidic nature in the refractory material, and this refractory material reacts with or attacks the basic slag. When there is a molten metal, there is a slag floats on the top of the surface. So the basicity or acidity of the slag has to be determined before selecting the refractories. If you use the acid refractory, then you cannot use the basic slag. Or in the process where the basic slag is generated, you cannot use the acid refractory. So you have to be very careful while selecting the refractory. So what are the acid refractories? I am defining it here. The super duty refractory bricks, the lining of aluminium melting furnace, rotary kiln, blast furnace, hot metal transfer ladle. These are the super duty fire clay bricks. These are all acidic brick. And high duty fire clay bricks, I will explain it. What are the high duty bricks? What are the super duty? The lining of cement and lime kiln, blast furnace, incinerator. Third is the high alumina bricks, boiler furnaces, spent acid, regenerating furnace, phosphate furnace, glass tank, refiner, carbon black furnaces, continuous casting, tundish, we call it the concuss machine, coal gasification reactors lining, and petroleum coke. Mind that these are all various industries. Mainly one of the maximum use of the refractory is the glass industry and petrochemical industries, apart from power plant and other thing. Silica bricks, the coke oven, ceramic kiln, a chemical reactor, linings, glass tank, the parts. These are all the use of the acid refractory. Next slide. Refractory based on chemical composition, basic refractory is mainly the basic refractories used are more or less limited here. Magnesite refractory, dolomite refractory, magnesite chrome refractory. Magnesite refractory, 85% magnesium, and high slag resistance and strong abrasion and corrosion resistance. Dolomite bricks are usually costly bricks. Mainly all the steel plants are used where your converters are there. Particularly steel plant technology use the all basic process furnace, BOF we call it. Dolomite refractories are used quite considerable, and in case of aluminum extraction or aluminum melting, these bricks are quite used. It's a costly brick, so it has high strong abrasion and corrosion resistance, apart from the temperature. So these are the chromite and magnesite. There are other kinds of calcium bricks are also there. Next is, we call it the neutral refractory. This is very peculiar nature of neutral refractory. They do not react neither slag or basic of acidity or basicity doesn't attack them. The acidity of the slag or the basicity of the slag doesn't attack this refractories. And mainly, particularly in case of this, we use it as an example is your induction furnace, where we call it the neutral refractories are there. The carbon graphite refractories mainly works as a reducing. Mind that when you use the carbon graphite refractories, quite a useful neutral refractories, but you cannot use the oxygen is the enemy of this carbon graphite, because they will oxide the carbon and the carbon dioxide will eliminate. All this will be jeopardized. So very careful about when you use the carbon graphites. We have to use in the reducing atmosphere. Then chromite refractories, composed of sintered magnesia and chromia. They have constant volume at high temperature. This is a very good chromite refractories, very costly refractories. The volume stability is very high for this refractory. Alumina refractories, composed of alumina 50%. This alumina 50%, we have you have alumina refractories. High alumina refractory is not the neutral. High alumina usually is the acidic refractory. Now the next slide is the refractory based on method of manufacture. So there are different manufacturing methods of making the refractory. Mind that these are all ceramic materials. So powder metallurgy is technology. We have to have the powder metallurgy. We have to have different powders. Different ingredients are powders. So aggregates are to be mixed. They're screened, they're dried, they're crushed, and then they're mixed. And they're fused cast process and molded process, formed, unformed. So the different varieties. I'm not going into detail. We have hours of lecture for different. I am switching out the next slide. The refractory based on fusion temperature. We have the refractory type of fusion temperatures. The normal refractories are 1580 to 1780. High refractory is 1780 to 2000. Super refractory, more than 2000. I will talk to these refractories afterwards. Super refractories. Next is refractory properties. What the refractory properties are? The physical properties, the density, porosity, strength, and abrasion. And refractory may be either dense or the porous come dense. In somewhere it is being used dense. When it is very close to the liquid metal inside the furnace, it has to be dense. So density is it cannot be very porous, otherwise the hot metal will impregnate them. So it is very careful about this. Where the density is a factor, porosity is there. The only is the insulation purpose. When with the ice outside the cylindrical surface, when it is a porous refractory, which is for the insulation purpose. It is quite strong, and strength means that it is quite strong. The abrasive strength is quite high, and the strength is there, and we call it a compressive strength. The refractory doesn't have much tensile strength. It may be a little bit. There should be one flexural rigidity to avoid bending, but there is no very poor tensile strength. Thermal shock and conductivity diffusion, these are all properties. The thermal shock resisting, conductivity, it has to be less conductive other than your metal refractories. Metal refractories are conductive refractories like tungsten, tantalum, all these things are conductive. The conductivity is good for metal refractories, but non-metallic it should be poor conductive, otherwise heat will take away from the furnace. So conductivity has to be low, less diffusibility, diffusion is less. The chemical composition is very important. Out of all properties, the most important property is the corrosion and erosion properties. So as I told you earlier, that you have to prevent corrosion. When the hot metal is there, the hot slag should not corrode the refractor. So you have to be very careful about the selection of the refractory vis-a-vis the hot metal, the slag used there in the process. Next is based on refractoriness. So it is the primary refractory should have a sound refractoriness. What is the refractoriness means? Refractoriness means that it will be like this. It will not lose it will not be softened due to heat. It will not be softened due to heat. And these are the parameters to finding out the refractoriness as per the STM. So these are we call the pyrometric cone equivalent. This is a feature of the refractoriness of the material, and there is a testing for that. We have to method. We are not if I will tell you the test, but we will not elaborate the testing methods. But it is a very common method of testing of refractoriness. Pyrometric cone equivalent, that you have to prepare a cone. You heat this cone, and cone will not melt and bend and touch the base. This is the method of finding out the pyrometric cone equivalent. The temperature is the very critical. So the refractoriness is the temperature by which we can find out whether it will be softened or melted or something like that. Pyrometric cone, the thermal softening behavior of a refractory material is known as refractoriness, which is determined by the pyrometric cone equivalent, or called the PCE test. And it is done in a PCE furnace. PCE of a refractory material is about its ability to withstand elevated temperature without appreciable deformation. The PCE test compares ceramic specimen of known softening behavior, either in Orton or in Seeger test. Refractoriness is based on thermal conductivity. The refractory is classified by thermal conductivity. It's conducting refractory, silicon carbide, zircon is highly conductive refractory. Non-conducting refractory is silica and aluminium. Insulating refractory is calcium silicate, kaolin, zirconia. Is the insulating where the holes or the porosity is very high. Insulating refractory has to have a quite good porosity, otherwise it will conduct it. Types of insulating refractory based on thermal conductivity. So the insulating refractory reduces the rate of heat loss through the furnace wall, which causes high degree of porosity. Having a high degree of porosity, having possible 4 types. Heat resistance with application temperature less than 1100. Refractory is the less than 1400 degrees centigrade, less than 1700 high refractory, ultra high refractory less than 2000. So these are based on. So these are the broad types of refractory variability. These are the broad types of refractory we handle in our engineering use, particularly the metal, iron steel. Iron steel used almost 70% of the refractory. Whatever I described, iron steel industry consumes 70% of industry. I was with RN Industries for many years in the steel plant, all this steel plant or mini steel plants or small refractory particularly in the Odisha and Bihar area. I have seen a lot of applications. The lot of refractory units are there here in Bihar. And the Tata Refractory is a very good unit there at the Odisha border, Bihar Odisha border, and Jharkhand area. So these are the all refractory. This compose, this bricks, almost 70 steel industries compose all the 70% of this type of refractory is used in steel industry. So I just elaborate this fired refractory products, non-fired refractory products, special refractories, monolithic refractories, very useful monolithic refractories, functional refractories, clay bricks, high alumina bricks, silica bricks, magnesite bricks, corundum bricks, ramming materials, plastic material, casting materials. So these are all refractory material based on refractory. Whatever the materials I have described earlier, the ingredients are off from that. Fire refractory application obtained by kneading, molding, drying, high temperature firing of granular powder, raw materials, and binder. Fire refractory bricks are shaped. It is used in wall, floor, and roof of a furnace. Whatever the furnace is doing, you have a wall, roof. These are very shaped material. They have a particular size, as I already showed you. The standard size is there. Non-standard, there are non-standard bricks, but non-standard bricks are very costly. You cannot afford for your furnaces. Non-fired bricks are the non-fired refractories are mostly granular and powdered, which are directly used without firing. Special refractories. Special refractory is a kind of refractory material with special features made of one or more high melting point oxides, refractory non-oxides, and carbon. Monolithic refractory is very useful. Monolithic refractory is a bulk refractory concrete, we call it, because in the industry a lot of non-forming or non-formed, unformed refractories. Monolithic refractories refer to refractory materials with a reasonable gradation of granular powder, refractory raw materials, and binders and various admixtures that are not fired at high temperature and used directly after mixing, molding, and grilling. It is not fired, but grilled. Like we grill our sandwich before eating, like this. It is not fired. Then who does the firing? The furnace does the firing. The site does the firing itself. The process firing does. So it got its strength by firing inside the process, not before that. The functional refractory is fired and non-fired refractory materials that are mixed with powdered and granulated refractory raw materials and binders to form a certain shape and have a specific melting applications. These are all functional refractory. You can do the refractory as per your functions. The use of refractory is as per your function, as the system or the process desires. So you can mix it, admix it, and mix it, and do it. The clay bricks, aluminum silicate refractory bricks called the clay bricks. So I skip some of the things like high aluminum bricks, which are shears, the silica bricks, magnesite bricks. I skip it. Corundum bricks, ramming material. These are all plastic material, casting materials, and these are all industrial bricks. The aluminum, I just explain it how high alumina, high percent. These are acetic bricks have high alumina, having high percentage of alumina from 50 to 99%. You please go ahead, change this. You go shift it. I'm going quite fast. Types of okay. The types of industrial refractory material. Acidic refractory material is different. You can have a silica, you can have a fire clay, have a high alumina. Your normal alumina bricks are neutral bricks, but high alumina bricks are acidic bricks. High alumina bricks can take huge costly bricks. High alumina bricks, costly bricks having they take quite a high temperature. It can resist high temperature with a 50 to 99% aluminum. Silica refractory brick is a very common use of silica refractory bricks. Fire clay refractory, like a cupola, you can have quite a fire clay refractory bricks in cupola. The basic refractories are the magnesite brick, lime, and thing. The composition of application of some acidic refractory brick. These are the composition, the acid type, or you can have a composition. How is the composition? you have that by changing the composition, changing the alumina, you see the high temperature. You can classify the high temperature alumina bricks by increasing the alumina percentage. So it's a very costly brick. High alumina bricks are quite costly brick. Now we could. So next is the use of refractory liner in iron and steel industries. Refractory bricks and liners. These are steel plant. May not be of interest to your all the maybe 1-2 units or maybe the Foundrymen, but it is a overall iron industry because I cannot skip coke oven. Coke oven is the ingredient where you can get the coke. We can feed your foundry. So I cannot give the blast furnace. Blast furnace give the pigs. We cannot eliminate blast furnace. You can't, if you don't get pig, you cannot run your cupola. So these are all integrated. And here you will find these are all real iron steel industries, bulk of this thing. And some of the things are not these other. Next. Application of acetic refractory, super duty fire clay bricks, lining of these I already have told you. Super duty fire clay bricks, lining of aluminium, melting furnace, rotary kiln, blast furnace, high duty fire clay bricks, lining of ceramic, cement. Cement industry is quite a refractory requirement because of their rotary furnace, rotary kiln, and even the high alumina bricks, boiler surfaces, paint acid generation furnace, phosphate glass tank refiner, carbon black furnaces, continuous casting, petroleum kiln, like the silica bricks. Basic magnesite bricks, I already tell you, and the basic oxygen is a huge requirement of basic refractories for steel plant. Your basic oxygen process, BOF, we call the BOP or BOF, basic oxygen furnace, so we call the converters. Now you switch on to basic, go to the basic. Next slide. Application basic refractory bricks. It is called the magnesite brick, basic oxygen process furnace lining for steel making. So I have explained where this type of refractory bricks are used there in the steel plants. These are these are being used where the coke oven, the silica bricks, rotary kiln, super duty fire clay bricks, rotary kilns in the DRI or the sponge iron. You find plenty of. If you go to the Odisha belt and other thing, the Jharkhand, even in the Raipur area, you will find quite a number of rotary kiln where you can the sponge iron. Sponge iron is the main ingredient for your steel plant. Many steel plant you don't have sponge iron, you can't run mini steel plant. But integrated steel plant doesn't need any sponge iron. Sintering surface, sintering furnace in the integrated steel plant, silica bricks, blast furnace, super duty fire clay bricks, cupola alumina bricks. You can use alumina bricks. The fire clay bricks also you can use it. Steel melting furnace. This is typically of, if you out of the all furnace, you will find only the magnesite bricks are used because it's a basic bricks. The basic process you cannot do the acidic. Any of the bricks you cannot use it here. The whole the furnace will be under disorder. So the use of proper selection and use of proper refractory is very important because otherwise your efficiency of the furnace will go down. So your energy, so costly energy is being wasted. Induction furnace, neutral bricks. As I told you, aluminum magnesite. You can have a graphite also. You can use graphite also, but only the thing graphite is that you be very careful about the environment there. You cannot any oxidation is prevented there. Only the reducing atmosphere you can use it. Arc furnace, high aluminum bricks. Arc furnace is very peculiarity of arc furnace. There is a arc spots are there. There's a intermittent arcs are there, which is high temperature, which causes the inside lining is the arc spots, or we call the continuous casting. Concast machine is called the high aluminum bricks. Billet reheating furnace, because before rolling, billet reheating, where do you use before rolling? You have a lot of reheating furnaces are being used in industry. Even for heat treatment furnace also, reheating furnaces are used. It is not a very high temperature, but it is a very useful furnace. You can have use this with the high aluminum bricks. As I already told you, these are the neutral brick and aluminum. Oh, next is the failure of brick. When refractory bricks fail, a lot of theories are there, a lot of articles are there, a lot of research papers are there. But I am just giving a few tips there. Here, the mechanical, even a blast furnace have different zones at different temperatures. The top zone where the charging is there, the refractories are subjected to mechanical fracture, mechanical wear, because materials are falling there. Productive gases, combustion gases is moving up. So the materials are being subjected to the products of combustion, and the refractories are subjected to falling materials. So it is falling, and they have a impact, a breakage, abrasion. These are all mechanical fractures. The fracture strength of the brick has to be high. The fracture strength of the brick has to be high. Though we have already discussed the strength of the brick doesn't have much tensile load. Tensile load is not much. So we are in tension, but they are strong in compression. The thermal reasons, thermal fracture, there with thermal fracture, the spalling caused by irregular contraction and expansion and quick heating and cooling cycles. So these are the a refractory brick is subjected to, not in the steel plant, but in many other things, particularly heat treatment plant, where there is heat treatments are there. When the thermal cycle, cooling and heating cycles, the brick has to withstand this cycle. Otherwise, there is spalling, there is a breakage. Because I tell you, it's a polycrystalline polyphase material. So their contraction and expansion is not of reversible nature. It's very important. The contraction and expansion are not of reversible nature. They're irreversible process. So that causes the cracks. So this has to be taken care of by selecting the refractory. Hot spot, we call the hot spot burn due to the high heat process, particularly in the arc furnace. The arc furnace, the arcs are there. There is a hot spot nearing the inside this. The chemical reason is the most important part. Is the chemical reason, as I told you, the corrosion and erosion. Mechanical failure, I explain it to the mechanical strength of the refractories indicate the resistance to mechanical fracture. Refractory bricks are made of aggregates. Strength varies from 4 megapascal to 10 megapascal due to size and aggregates distributions. So the distribution is a very important. As I told you, it is not a homogeneous material. It's a heterogeneous material. Refractory bricks are heterogeneous material. There's no homogeneity in here there because it was all made of powders, aggregates, dust. Some are slightly bigger, some are smaller, and so due to their irregularity in distribution, the strength changes from 4 megapascal to 10 megapascal. And in fact, we must be very careful that very strong refractory brick is not needed, not desired, because if the strength increases, this will be subjected to fracture. So it will be our strength, fracture strength has to be increased, not the mechanical strength. So the silica bricks are more susceptible to breakage with intensity due to the grain growth at the boundary. You know, in the foundry, people who are the silica, the presence of silica have a grain boundaries. There's formation of grain boundaries, and this fracture happens in the grain boundaries. So you have to be very careful about deciding or choosing the proper refractory for the proper use. So use has to be very important. What the process demands, the temperature cycle demands, how the mixing is there, where the loading, how's the unloading. So this matters a lot regarding the selection of the refractory. Second is the load displacement graph. This is a normal, very standard graph here. You will find there's a slant line. The right side is called the tougher line. This side, left side, is called the brittle line. So we want a tougher side. We want to select a tougher line, so that it will can displacement, if at all there will be marginal displacement with a strong strength. We want a strength, not the brittle. We want toughness rather than hardness. If it is hard, it is brittle. If it's tough, it can absorb strength. It can absorb shock. So that is our objective of selecting. The chemical presence of failure of refractory is the significant cause of refractory failure is due to the slag corrosion and erosion of refractory. So these are the main, and the refractory damage of refractory is due to this. Out of all reasons, this is the biggest cause of refractory failure is the corrosion and erosion of refractory. Slag corrosion is the cause of improper selection of refractory material for the chemical process. Acidic slag will corrode refractory, basic refractory, or we can get the acidic slag will attack basic refractory. A basic slag will attack acid refractories. So there is a test for that. B is the basicity by acidity. Test of slag is needed for refractory selection. Where the B is called the CaO, A is called silica. So the calcium divided by silica. So these are the ratios. This ratio is is needed for refractory selection. When B by A is near 0.25 acid, you select acid refractory. When B by A near 0.75 basic refractory. If it is in between, go for the neutral refractory. This is the thumb rule for selection of the type of refractory used in. So I just define a furnace. It is just an academic. Whatever the furnace I have given you, I just defined the furnace is enclosure where energy is in non-thermal form is converted into heat, and we conserve the heat, preserve the heat, and the heating to be used properly, and it should be energy efficient. The furnace has to be energy efficient. Whosoever designs the furnace has to look at the energy efficiency, because today energy cost is so high. You have to conserve the energy. That way, refractory is a big role. The heating only for solid phase, it is heat treatment and reheating furnaces. Heating for melting, cupola, induction, and arc furnace. Mind that cupola, induction, arc furnace is not the reduction furnace or the process. It is just heating the process. Smelting furnace, where the redefine or the ore is to be reduced, is a reduction furnace. The blast furnace is the king of all furnaces. Blast furnace is the king of all furnaces in the steel and iron industries. The melting point I have derived because it is very important to know the melting points of the metal, because when mostly we do the iron and steel industry, it is 93% of the world's metals consumption is iron and steel, as per the information from USA. Whatever we consume iron steel in the world, 93% is steel, iron and steel. 5% is aluminium. So you know that the importance of aluminium, steel. The rest is all other metals. So these are the melting furnace. So I have shown you the cupola. This is my area of interest, many of the things, and the charging. And you will see that you see the color. You see the color inside is different. The upper side is a reddish color because the temperature is less. Lower side, the emission or the radiation is different. From radiation pyrometry form, the lower side is a whitish because the temperature is very high. So when this high, the lower zone where the hot metal, the most severe conditions is faced by the refractory. The severity has to be judged, and you have to select the refractory. So you have all options. You have to severity has to judge. So you are the refractory designer, you are the supplier, you are the contractor. Particularly refractory contractor has to know all these things. Which one to select there, and they are quite qualified and they are suitable for the purpose. The lower side is a hot furnace where the temperature is very high, and all these things are to be used like that. Next is the coke oven battery. I'm very much being a steel plant man, and this coke oven is a very important area. Mind that this is a very important area in the sense that we use coal. Not only we use coal and convert it into coke, but by the process we leave lot of byproducts. It's a very rich byproducts, very costly and rich byproducts. And the coke oven gas is very costly. The coke oven gas almost balances the all gas. There's a gas circuit in the steel plant. Coke oven gas is quite rich in ammonia, so it is its calorific value is quite high than the blast furnace gas or BOF gas, sintering gas, all these things. And this is coke oven is very important because it gives coke and other byproducts. And a very dirty place in the steel plant. This is a coke car. the pusher that pushes the coal and the coke. The material is being, the hot chunk of material comes to here and is being sprayed and then is used and transported to the bunker. This is the coke oven battery, and this is the series of batteries. This is the lengthy, long series of batteries, coke oven batteries. If you go to any integrated steel plants, not very much in, not many in numbers, 8-10 numbers in there, you will find this is the starting point of a steel plant, where silos are there for the raw coal, and it comes, or the tipplers are there from the wagon, and they tipple it to the silos dump it here, the coke oven process. This is this lengthy, like the cabinet, or like a rack in your library. It looks like a rack in your library, but it is all the coal coke oven furnaces, because the battery, coke oven battery. This is called the rotary kiln. This is a sponge iron, or we can the sponge iron. You can have a cement. You have the calcine coke. Your coke can be, or coal can be, or your limestone can be calcine. All this, where the calcination. Even the magnesium or the dolomite has to be calcined. So this is the refractory or the sponge iron. We rotating the sponge iron also. These are all rotary kiln. We call the rotary kiln used in they are rotating. Very small, 5-6 rotations per minute, but it is on the diameter maybe of 3-4 meters, as long as 80. Next, please, next. This is also rotary kiln. Rotary kiln. Next, this is a cupola. I just give. We are coming to that point. It's a cupola. Since we are the Foundrymen, it is our very ingrained cupola. Now it's a divided blast cupola. Divided now it is our present day. We don't use a cupola. Cupola is being used. It's very important, because sometimes we call the shaft furnace. We call this the long shaft, maybe 20, minimum 25 or 30 feet, a minimum. The door closed. The door is there. You can open the door. It's an intermittent furnace. In a particular day, you can have one. It can operate in a day. But blast furnace, unlike blast furnace you have to run for entire year, except the capital repair of the furnaces. Mind that blast furnace run 24/7 for an entire year, except the 13 or 14 days they will give for capital repairs of the lining, brick. But cupola is, on the other hand, is a heating furnace, just to heating and adding carbon to the hot metal. So there's a slag door and all this charging door, and you can charge it. Inside all the liners are there, and you see both the principally principal things are same. The bottom of the hearth is the high temperature zone, and top both are cupola, and there is a similitude of the cupola and the blast furnace in the sense they are the very tallest. And but the blast furnace capacity is being this molten metal part here, because the volume capacity we measure, but here tonnage capacity in cupola, 10 ton, 20 ton, 30 ton, like this. But in blast furnace we measure the capacity by 2000 meter cube volume of this, and one charge, one tapping, the entire material will come out. So this is the volume of the blast furnace, and both are thing we call the shaft furnace, because this is a long, tall, and your productive combustion will go up. The temperature, if you go upper side, the temperature goes down. Lower side temperature, hearth is very heated. So your size of, or your type of bricks has to be suit to that your requirement, what it desires. So this is the LD converter. You will see this is a very useful converter. LD converter is for steel plant, where we call the converters, where the materials from the blast furnace is being used for reduction of the carbon, 4%, around 4% to 0.12, 0.13, or depending on the situation. So here you see the picture is a slag lancing of oxygen lancers you are giving in the oxygen. oxygen lancers. This is the pipe we are giving the oxygen lancing. A huge oxygen is required. We have a separate oxygen plant for this in the steel plant. During COVID time, you have noticed that we are searching for oxygen, and the people died of in our zone in the eastern region. A lot of people died of scarcity of oxygen, and that time the steel plant supplied this oxygen cylinder, particularly in the Tata Steel. Tata was so even he supplied oxygen cylinders from your oxygen plant. So this oxygen being supplied here, it is being, and mind that these are the all basic slag. This is only here, your liners of the basic refractory is being used, the basic oxide process. So these are the other part I'm going. These are of a lower important material because the rolled material is being rolled by the billet reheating furnace. It's very useful for the rolling mill, where you can have a furnace and this billet heating. This is not very high temperature furnace. It is a recrystalline temperature around 800, 900 degrees temperature, because the billets, the cold billets are to be reheated. Sometimes the heated billet comes here. It is being rolled. So the temperature is not much. Whereas in the blast furnace, temperature is above 15, around 1600 degree temperature. So the temperature is a very important parameters for selecting the refractory, and the type of refractories and the atmosphere. So these two parameters are very important selecting the refractory. Temperature and the atmosphere there is the acidic atmosphere, basic atmosphere. So these are the two proper guidelines for selecting the. So here the reheating furnace. Now the basis for selection, as I was talking about the thermal requirement, the temperature, physical properties are mechanical. Third is the corrosion. Fourth is the installation logistics. Very important for the logistics. How will you do it? I can give you an example that a LD converter of 150 ton capacity requires 6 crore for replacement of your refractory. 6 crore rupees for replacement. It's a huge time. And this is you have to lay all the joining of the plant and this thing. So I am giving you, and it can cover around 850 heats. One heat around 2 hours. One heat around 2 hours to make your pig iron to steel. This is the statistics of the steel plant. So these are the parameters. How do you select a refractory? Physical property, this thing. Refractory manufacturing, very important is the refractory. How do you manufacture refractory? I told you it is a ceramic material, so it is a powder metallurgy technology. So you have to make it powder first. So normally the refractory starts from 538,000 degrees Fahrenheit, but there are the upper limits for this. This starts from 538 degrees centigrade. We can call it a refractory material, which material instant 538 degrees centigrade. Two types of clay, and non-clay type of refractory. One is clay, made of clay, hydrated silicate of aluminium or alumina, kaolin, ball mill, ball clay, bentonite, and normal clay, etc. Non-clay type is the alumina, silica, mullite, chromite. These are from minerals. Mind, these are made from minerals. By crushing the minerals. Before crushing, maybe sometimes we have to calcine it. We have to calcine it, make it manganese carbonate into manganese oxide, magnesium oxide, like this. Magnesium carbonate to magnesium oxide, the calcium carbonate to calcium oxide. So you have to calcine it. So there we have a calcination furnace. For calcination process, normally these furnaces are the rotary furnace. Two types of bricks are the formed and shaped and. So what are the processes there? Mind that the raw materials grinding. After calcining, I'm not adding here calcining the refractory. Before grinding, you have to calcine it. Grinding. Ball mill, you can have a ball mill, or you can have a pan mill. You can have the small, you can have a pan mill. Screen, these vibrating screens are there. If you with the Tata refractories or if the Dilpa refractories, you find all these processes are there. Tata doesn't have their own refractory plants. The public sector steel plant have their own refractory plants. Mind that. All public sector plants, they have their own refractory plants inside their unit. Tata has a separate, they don't make it inside their own unit. They purchase or bought out item from other other sources, and that too is from the Tata organization. Screening, it is a screen for particular sizes. Very important, the sizing. Other, it is basically a heterogeneous material, but if the sizes are to be not properly screened, the material will not have the desired property. Cracks will develop, porosity will be more. Forming by press, it is by press work, mind that. Mixing, the mixing process may be in pan mill or maybe counter-current mixture. The different materials, different type of quality of refractory bricks from 500 rupees to 5,000 rupees one piece, or kg of 500 to 5,000 rupees, depending on the use and the application. So for the refractory made from 5,000 rupees will have a different properties or different manufacturing thing. They grind the surfaces up to me. So I am telling you, the forming by the press, maybe friction screw press. Firing, sintering, firing maybe in the dome furnace, where you will find in the local or the fire clay bricks, but it may be a tunnel furnace. Bogie there, the size in the bogie, they push it with a rail, they may. In milling, the surface after firing, they're cooling it down, then they mill the surface because of the dimensional tolerance. Everything has a dimension tolerance as per ASTM. As per ASTM, the American Society of Testing and Materials. So it has a, if you have to follow the guideline of this ASTM. Milling means the surface has to mill, machining. You can grind if you then sandblasting. These are the very sophisticated. So these are the different process, different machineries that they are being used. Huge setup is there. Now the quality test of these are the all quality tests. These are the abrasive resistant test, acid resistant test, air permeability test, physical. These are all physical testing. Bulk density, apparent porosity, cold crushing strength, pyrometric, as I told you, pyrometric conic. These are all mechanical tests. Particle size detection, modulus of elasticity, modulus of rigidity, water absorption, size and dimension stability. Mind you, these are as per ASTM. Now the chemical test. Chemical composition by X-ray fluorescence. Chemical composition by D, X-ray diffraction. These are the chemical tests. Now thermomechanical test. Thermomechanical is very important because why thermo? Because you mechanical test you under temperature. You have to test it mechanical under temperature. Compression test in up to 1500 degrees centigrade because all the inside the furnace there is always under heat. So you have to test it not on ambient temperature or your room temperature. Thermal conductivity, flexural stress strain, thermal shock resistance, thermal expansion up to 16 degrees centigrade, creep test in compression up to 1550 degrees centigrade, specific hit, refractories under load, RUL, very important test, RUL under load. Because all refractories, when it is sized up in the stacked in a furnace, they are under load. One refractory is above another refractory, so they are under load. Permanent linear change, it is called the stability, size stability, or the dimensional stability. It's very important. So these are the all I complete here. Thank you very much for joining it. Thank you, sir. Thank you for having a patient hearing. If you have any question, you can come up. Or you can, one thing you can do, due to that, you can mail me. I request you mail any question. I will answer everybody, I tell you. Give me some time, I will answer everybody. You mail whatever your questions are.
All right, sir. So thank you very much, Sanjeev, sir. It was a fantastic presentation, taking us through the basics, characteristics, and the uses of refractory and bricks. So if anybody has any questions, you can ask it right now, or like what sir said, we can have the mail. You can send it by mail.
Give them the mail and I will attend it.
Yeah.
I will attend each and every questions raised by your all Foundrymen members.
But at the moment, do we have any questions?
Thank you, sir. Let them take some time and put questions.
Right. So in that case, I think we can proceed with the vote of thanks. So, gentlemen, we've indeed had a very interesting topic today on refractory bricks and material. We are sure the content of the talk had a lot of takeaways for our audience. We'd like to thank Mr. Sanjib Chakrabarti for taking time off his busy schedule and making us rich with knowledge. Uh, so further, we'd like to thank all the members who joined us on time, and thank you for acknowledging our WhatsApp and mail invitations and joining us. I'm sure you had a wonderful learning experience, and thank you for joining us. We from the Chennai chapter will be conducting many such interesting programs, and we'll be sharing information with you soon. Looking forward to seeing you all in our upcoming programs. Thank you very much, gentlemen.
Thank you, sir. Thank you very much.